Welcome to the deep dive. Today we're getting into something called self-consistency prompting. It's a really interesting technique for making large language model outputs more reliable, more accurate.
That's right.
And for those of us working deep in generative AI, well, you know the power's there, but sometimes the reasoning, it can be a bit shaky.
Absolutely.
So our mission today is to really unpack this method. We think it's a key way to get more trustworthy solutions from LLMs, especially for, complex stuff.
Definitely. And the core concept, it actually mirrors how experts often work, doesn't it? We rarely just take one viewpoint. We look for different angles, different expert opinions maybe, to build a stronger conclusion. Self-consistency sort of does that inside the LLM.
So instead of one path to an answer.
Exactly. You push the model to try multiple independent ways of thinking about the same prompt. And the real magic happens when you look at those paths and find the most consistent result. It's about getting past the limits of just one, maybe flawed, line of reasoning.
Okay, so let's connect that to something probably familiar to a lot of our listeners. Ensemble methods in machine learning. How does self-consistency prompting line up with that?
Yeah, it's a really strong parallel. In traditional ML, ensemble methods mean you train several different models, maybe different architectures, different data slices, and then combine their predictions.
Right, a standard technique for better performance.
Precisely. And it's well known to boost robustness. Self-consistency takes that same kind of thinking, that ensemble idea, but applies it within a single large model.
Oh, okay.
By asking for and getting multiple reasoning paths, you're basically creating an internal ensemble of thought. Just like combining different models averages out errors, comparing these internal paths helps reduce the risk of trusting one faulty line of logic.
I see, so it's like an internal cross-check.
Exactly. And for anyone needing high confidence in LLM results for critical tasks, that's incredibly valuable.
So the LLM is essentially showing its work multiple times using different routes. What are the real practical benefits of doing it this way? Seems like more effort.
It is a bit more involved, but the payoff can be significant. First off, generating multiple solutions gives you this built-in way to compare, to validate, and then synthesize.
Okay.
When different independent lines of reasoning all point to the same answer, well, your confidence in that answer just shoots up. It's like hearing several experts agree independently.
Makes sense.
And second, it's actually really good at uncovering potential blind spots or biases that might be hiding in a single reasoning path.
How so?
By making the model try different approaches, you're kind of stress testing its understanding from various angles. It forces a broader look at the problem space.
So it's like getting those multiple expert opinions, but the experts are different reasoning processes within the same AI.
Yeah.
Can you walk us through an example, maybe something concrete?
Sure. Let's take a math problem, like the one in our sources. What is the area of a circle with a circumference of 12? A basic prompt might give you one answer, one method.
Right.
With self-consistency, though, you'd prompt it to solve this using maybe 3 different methods. Path 1 might use C shu par to find the radius, then A equals hor.
Standard approach.
Yep. Path 2 could use C par to R to find the diameter first, then radius, then area. And maybe path 3 uses a less common formula, like A equals C4 directly.
Interesting. So the trick is pushing for genuinely different mathematical routes, not just, say, rearranging the steps in the first method.
Exactly that. And in this case, all 3 distinct methods independently give you 36 GAR units. That convergence across different logical procedures makes you much more certain the answer's right.
Yeah, much harder for it to be a fluke or a calculation error that coincidentally worked out if 3 different methods agree.
Precisely. A single path might get lucky, but 3 independent ones, much less likely.
Okay, that makes sense for math, where there's a definite right answer. How does this apply in fuzzier areas, like, say, business strategy?
The core principle holds. You analyze the problem from multiple independent viewpoints. Let's say you're looking at entering a new market.
Okay.
You could prompt the LLM to analyze this using different frameworks. Maybe one path uses Porter's 5 forces, looking at competition. Another path could be a SWOT analysis, strengths, weaknesses, opportunities, threats. And a third might be a purely financial model projecting revenue, costs, ROI.
So you wouldn't just get a simple go or no-go. You'd get reasoning based on these different lenses.
That's the idea. The final decision isn't just based on one analysis. You synthesize the insights. You look for agreement, but also disagreement.
Well.
Maybe Porter's 5 forces shows intense competition, but the SWOT highlights a huge opportunity aligned with your strengths. And the financials look good despite the competition. So by pulling these together, you get a much more nuanced and robust evaluation. You avoid making a big call based on just one, possibly narrow perspective.
That really highlights the strength. It's about the robustness of the reasoning, not just the final answer. So what are the fundamental principles making this work so well?
There are a few key things. One, multiple perspectives just inherently reduce blind spots. Any single approach can miss things.
Makes sense.
2, that cross-validation you get when different paths converge, that really boosts confidence. It's like internal triangulation. 3, the process of finding consensus forces a tougher look at the problem. If paths disagree, you have to figure out why, which deepens understanding.
Right, you have to reconcile the differences.
Exactly. And finally, just exploring through different lenses often reveals facets of the problem you might otherwise miss entirely. For expert users, that richer picture is often crucial.
Okay, this sounds powerful. For people wanting to actually use this, what are the practical things to keep in mind? Implementation details.
Good question. There are definitely some key considerations. First is the number of paths you generate.
How many is enough?
Well, there's no magic number, but aiming for maybe 3 to 5 genuinely distinct paths is often a good starting point. The key word is distinct.
Not just minor variations.
Right. You need truly independent lines of thought, and you have to balance this against computational cost, obviously. Too many paths gets expensive fast and might not add much more value.
Okay, 3 to 5 distinct paths. How do you ensure they are distinct? What are the strategies for path generation?
That's crucial. You can prime the model differently for each path, maybe give it slightly different starting assumptions or constraints.
Okay.
You can also explicitly tell it to use different methods or frameworks, like the business example we discussed.
Got it.
And sometimes you might even prompt it to consider opposing viewpoints or alternative scenarios. The goal is active steering towards diverse reasoning.
Okay, so you've generated these diverse paths. How do you actually perform the consensus building? What does that look like?
It involves looking for the overlap. Where do the paths agree? Are there common intermediate steps or conclusions? But just as importantly, you need to spot the contradictions. Where do they diverge and why? Understanding those discrepancies is key.
So you might need to dig into the reasoning of the conflicting paths.
Absolutely. And in more advanced setups, you might even assign some kind of confidence score to each path based on its logic, and then weight the final consensus.
Interesting. Not just a simple vote count. What about presenting this? The output format must be important for usability.
Critical, especially for expert users who need transparency. You really want to clearly show all the reasoning paths, the steps, assumptions, conclusions for each one.
Lay it all out.
Yes, and explicitly point out where they align and where they differ, and then, importantly, explain how the final consensus was reached, what was agreed upon, how were conflicts resolved, was weighting used. That transparency builds trust.
And I assume standard quality control still applies. You don't just trust the consensus blindly?
Oh, absolutely not. Quality control is non-negotiable. You still need to independently check each reasoning path for logical soundness, factual accuracy if relevant, and whether it actually followed the prompt.
Right.
Even if paths converge, they could, theoretically, share the same subtle flaw. So, expert human review of the steps and the final synthesized answer. Still essential. Self-consistency improves the odds of correctness. It doesn't guarantee it.
Good clarification. So where does this technique really shine? What are the ideal use cases?
It's particularly strong for complex problem solving, where lots of factors interact, and a single view might be too simple.
Go.
Also very useful in decision-making under uncertainty, where you need a really solid justification backed by multiple angles.
High-stakes decisions.
Exactly. And anytime validation of critical conclusions is vital, think research, engineering, serious strategy, this adds a layer of confidence.
Yeah.
And fundamentally, it's a great tool for just reducing those inherent reasoning errors LLMs can sometimes make. It leads to more dependable outputs overall.
This has been really illuminating. Self-consistency prompting. It's clearly a sophisticated tool, but one with real potential for, boosting the reliability of LLM outputs, especially for expert needs.
I think so too. By making the model generate and then letting us evaluate multiple lines of reasoning, we can use these powerful tools with, frankly, more confidence. We know the conclusion has been stress-tested internally.
So a final thought for our listeners. As you think about this technique, consider how those core principles, getting multiple independent takes, looking for consensus, might apply beyond AI.
Interesting point.
Could it change how expert teams collaborate in your field? How research gets validated? How big strategic calls are made? It's definitely a powerful framework for enhancing rigor wherever complex thinking is needed. Thanks for digging deep with us today.